Okay, first we're going to start with a normal board that does not have underfill. This is a Vodafone 685 if I'm not mistaken. I already moved the grid there to reveal the chips underneath. As you can see there, underneath the chip here, we have those soldering balls that actually make contact with the chip and the board. Now, with a phone like this, usually what happens if it falls or maybe it's got a dry joint or there's water, what you can do is that you can put some heat paste on there and then heat it with a hot air gun and maybe bump the chips. But now it becomes a bit of a challenge when you have a board like this that's got underfill. This is a Hawaii Y560, and if you look around the chips there, you can actually see a bit of a shine. That shine is underfill. When underfill is usually applied to a board, it's actually in a liquid state at first, and it's heated to very high temperatures to get it to the solid state that you see here. So what that actually helps with is when the phone falls or gets some sort of shock, that the chips don't move or cause dry joints. That's the purpose of underfill. But now the problem comes in when the phone is either dead or it's got water damage, and now you want to reflow or heat the chips. You can't do that because you're going to get something called solder squeeze out. And what that actually does is the soldering or the solder balls found underneath these chips here actually squeezes out and comes out, and now some of the balls underneath the chips here actually end up touching. And well, because there's underfill, you can't exactly just remove the chip and then put it back on again. But now something to keep in mind, a board that has got underfill is not very likely to get rusting underneath the chipset. So you wouldn't usually have to worry about rusting happening underneath the chipset because it is completely waterproof underneath. It's actually waterproof underneath. But now what can happen is there are other components on the board that could get water, like for example underneath this grid here, which I've not removed. There's grids also on this side as well, so it can happen that something else on the board would get damaged, but it wouldn't be very likely to be one of these chips that has got underfill on them. Okay, so now I'm gonna make a very short video demonstrating what solder squeeze out is. Balls that have come out that have actually squeezed themselves out from underneath the chip. There we also have there in the corner there. That is something we don't want because that means this board is technically dead.